and compare them to malignant neoplasms. Now, we've already said before a few times that benign neoplasms grow locally. They have no ability to invade, no ability to metastasize, and that is by definition. Any kind of neoplasm that invades or metastasizes is not benign, it's malignant. Now, let's take a look and compare examples of normal cells to benign neoplastic cells. We're going to take a look at this. Compare normal fibroblasts to those of a benign proliferation of fibroblasts. Now, usually when we name benign proliferation, we take the original cell of origin, the rankable name of the cell of origin, and we add the letters OMA at the end. So, a benign proliferation of fibroblasts would be called a fibroma. Let's take a look and compare normal fibroblasts to those of a fibroma. Okay, let's first take a look at fibroblasts. And this is actually a section through scar tissue, and you know it's populated by fibroblasts and collagen. You can see we've got a nice population of fibroblasts. You can't actually see the individual fibroblasts, but you can see the nuclei and get an idea of just how densely packed normal fibroblasts are. Okay? If I look at this section and I use the nuclei as an indicator, we've got what looks like a normal distribution, normal density of fibroblasts. Everything looks good here. If I look at the morphology of the nuclei, you can see some nuclei have kind of an oval shape, some are kind of elongated, but all the nuclei and the fibroblasts look normal in this section. Let's take a look and compare the normal fibroblasts to a neoplastic proliferation of fibroblasts, a benign neoplastic proliferation of fibroblasts. Okay? That's what a fibroblast, section through fibroblasts looks like. Here's an example of what fibroma cells look like. This is a benign proliferation of fibroblasts, and you can immediately see there's some differences here. The first thing that strikes me as being odd is the density of cells in the fibroma. You'll notice that the cells are more densely packed in the fibroma compared to what they are in the scar tissue fibroblasts, normal fibroblasts. And that's because these cells have lost proliferative control. They lose proliferative control, they start crowding each other. Cells should never crowd each other like this. There should be a certain degree in which they proliferate and then they start to hit up against each other. They should contact inhibit each other, inhibiting each other from proliferating. These cells aren't doing that. These cells are continuing to proliferate until they crowd each other. That, by definition, is a loss of proliferative control. And, of course, all cells that have lost proliferative control, neoplastic cells. And that's indeed what we see here. These are all neoplastic cells. These happen to be benign neoplastic cells of fibroblasts, so we call them fibroma cells. Now, other than that, and maybe some different staining characteristics, there's really not much difference between the fibroma cells and the cells of the fibroblasts. You take a look and you compare the nuclei of some of these fibroma cells, they kind of resemble, for the most part, they resemble the nuclei of the normal fibroblasts, wouldn't you say? Take a look at them. I mean, it's not true for all of them, but you'll notice that most of the cells here of the fibroma resemble the normal fibroblasts. Okay. When neoplastic cells resemble their normal counterparts in appearance and function, we describe the neoplastic cells as being well differentiated. Well differentiated. They look like their normal counterparts. They're well differentiated. What you'll find is usually, not always, but usually, benign neoplastic cells resemble their normal counterparts. That is, very often, not always, but very often, benign neoplastic cells resemble their normal counterparts and therefore are well differentiated. Benign neoplasms tend to be composed of well differentiated cells. Now, that's not a defining feature of a benign neoplasm, but it is a very strong correlate. Usually, not always, usually, benign neoplastic cells are well differentiated. That is, they look like their normal counterparts. Sometimes when we are examining a tumor, we're going to want to know whether the tumor is benign or malignant. Now, we don't always have the luxury of observing local invasion or metastatic spread. Sometimes we have to use correlates rather than defining features. One of the correlates that we can use is to look at the differentiation of the cells that comprise the tumor. If they're well-differentiated cells, the tumor is probably benign. Could we be wrong? Yes. This is not a defining feature, it's a correlate. However, we look at the cells, look at the tumor cells, and they're composed of well-differentiated cells, that strongly suggests benignancy. Any questions on that? Okay. The other types of benign neoplasms. We got a number of different names for certain types of benign neoplasms. For example, sometimes a benign neoplasm originates from glandular tissue. It tends to make glands as it grows. Well, we have a generic name for a benign neoplasm that originates from glandular tissue and or make glands as it grows. We call that benign neoplasm an adenoma. An adenoma. An adenoma is a benign neoplasm that originates from glandular tissue and makes glands as it grows. It's a generic term. It's not the name of a specific tumor. It is just a name we use to describe a benign neoplasm that arises from glandular tissue and makes glands as it grows. Let's take a look at an example of an adenoma. We'll do this by examining a type of adenoma that develops in the thyroid tissue. It's called a follicular cell adenoma. Let's first take a look at normal thyroid tissue, then we'll compare it to a follicular cell adenoma of the thyroid gland. Okay, here's the section through thyroid tissue. You recognize the follicles you see in the thyroid tissue. These follicles contain thyroglobulin. They're surrounded by follicular cells. These follicular cells are usually kind of cuboidal in shape, and they kind of surround the entire thyroglobulin aggregate. These are the glands of the thyroid. These follicles, the glandular tissue of the thyroid. The job of these follicles is to resorb the thyroglobulin by the follicular cells, convert the thyroglobulin back into thyroid hormone, and of course the thyroid hormones regulate metabolism. Outside of these follicles, you can see some other tissue here, some connective tissue, some blood vessels. This is what we call the stroma of the thyroid gland. We got the glands here, and we got the stroma here. Okay. The stroma is just all this other tissue. It's all the supporting tissue, the connective tissue, the vascular tissue. So we got the glands here, and we got the stroma. Now these glands are surrounded by cells. These are called follicular cells. Okay. Sometimes these follicular cells, they lose proliferative control. And when they lose proliferative control, they proliferate trying to imitate the functions of their normal counterparts. The function of their normal counterparts is to make glands. So, as these follicular cells grow neoplastically, they expand as a neoplasm, they tend to make these odd-looking glandular structures. So if this is what normal glandular tissue looks like, this is what a benign neoplastic proliferation of the follicular cells look like. This is a follicular cell adenoma, a benign proliferation of glandular tissue. Okay? You can see the follicular cell adenoma here. You can see it consists of these glandular structures, okay? Some of which have thyroglobulin in them, some of which do not, but they're all lined by these benign follicular cells. Okay, that are proliferating in a benign way. Any neoplasm which is benign, is growing, producing these glandular structures, is referred to as an adenoma. This is an example of a thyroid follicular cell adenoma. Now, the neoplastic cells are actually these follicular cells. Again, when they're growing, they tend to recapitulate the functions of their normal counterparts, which is to make little glandular structures. And that's exactly what they're doing. Now, you see, as this follicular cell adenoma is growing, it's actually growing in a benign manner. It's growing by pushing up against the surrounding tissue, and as a result, surrounding tissue is kind of atrophying, and you can see here a pseudocapsule. There's a pseudocapsule. There's a pseudocapsule right there. And you'll notice all of the cells are respecting the boundaries of the pseudocapsule. There's no evidence of local invasion at all. This is a benign neoplasm. And since it's making glands, it's called an adenoma. Questions on that? Okay. All right. Let's take a closer look at some of the characteristics of neoplasms in general, what we've learned so far. So we said neoplasms can be subdivided to two major categories. We've got the benign neoplasms, we've got the malignant neoplasms. Malignant neoplasms can also be referred to as cancers. Benign neoplasms are not cancers. You can't call them that. However, since both benign and malignant neoplasms grow, making irregularities in tissue, bumps, you can collectively refer to all of these neoplasms as tumors. Tumors. They make bumps as they grow. Benign neoplasms are tumors, malignant neoplasms are tumors. We've also seen that the benign neoplasms sometimes will create these glandular structures as it grows, and some other benign neoplasms won't make glands as they grow. Well, the benign neoplasms that make glands as they grow, these are called adenomas. We've seen follicular cell adenoma. We've also seen something like a fibroma. Fibroma is a benign proliferation of fibroblasts. Fibroblasts don't normally make glands. They're not glandular tissues. And so when the fibroma proliferates, it does not make glands as it grows. And therefore, a fibroma is not an adenoma. It's what we describe as a non-adenomatous neoplasm. This doesn't make glands. So we've got these two types of benign neoplasms. We've got the adenomas that make glands, and we've got the non-adenomatous neoplasms that don't make any glands at all. Example, follicular cell adenoma. Example here, fibroma. Okay. All right, so benign neoplasms are pretty simple. You can just subclassify them as one or the other. Very simple subclassification for the benign neoplasms. Malignant neoplasms, their classification is very complicated. There are many different ways to subclassify the malignant neoplasms. Usually we subclassify them extensively because we want to customize a treatment for each individual type of cancer. The more we can customize a treatment for a cancer, the better we can treat that cancer and limit some of the side effects. And so subclassification of malignant neoplasms is very complicated. They are basically subclassified to death. Just subclassify them as much as possible. Okay? And that's really for treatment, for clinical management. However, malignant neoplasms can be broadly subdivided to two subcategories. We've got the sarcomas, and we've got the carcinomas. You've probably heard of these, sarcomas and carcinomas? Okay. What's the difference between sarcoma and carcinoma? A sarcoma is a malignant neoplasm that develops from mesenchyme. Mesenchyme. Mesenchyme is that primitive, undifferentiated tissue. Gives rise to things like fibroblasts. That's mesenchyme. Any malignant neoplasm in which the cells arise from mesenchyme will be called a sarcoma. Fibroblasts come from mesenchyme. A malignant proliferation of fibroblasts would be called a sarcoma. Specifically, it would be called a fibrosarcoma. Usually we name sarcomas by, again, indicating the cell of origin and just adding the word sarcoma on the end. So malignant proliferation of fibroblasts, we call it fibrosarcoma. Why? Because fibroblasts come from mesenchyme. That's all. That's why we call it a sarcoma. Carcinoma. What's a carcinoma? Carcinoma is a malignant proliferation of cells that originate from basically every other tissue. Remember those 3 embryonic tissue layers you learned about in embryology? The ectoderm, the mesoderm, and the endoderm? Any malignant proliferation of cells that originates from ectoderm, endoderm, or mesoderm are referred to as carcinomas. They come from ectoderm, mesoderm, or endoderm. Any malignant proliferation where the cells originate from any one of these 3 germ cell layers is referred to as a carcinoma. Example: the squamous cells of your skin, they originate from the ectoderm. Squames of the skin, okay, comes from ectoderm. What do you call a malignant proliferation of squames? Squamous cell carcinoma. Okay. Now, the sarcomas, they just kind of proliferate. They don't ever make glands. When they grow, they just don't make any glands. So the sarcomas are just sarcomas. They don't make glands as they grow. They tend to make very fleshy masses. In fact, that's where the name comes from. Sarcoma, sarcomatoid, means fleshy. Okay? They don't make any glands as they grow. So the cells of a sarcoma are just sheets of cells with no resemblance of any kind of glandular tissue at all. However, sometimes the carcinomas will make sheets of cells and will not bother making glands. But sometimes, when the cells proliferate, they actually make glandular tissue. The cells that make glands, or carcinomas that make glands, are referred to as adenocarcinomas. Okay? These are the malignant glandular tissue. Endometrium. Endometrium, the inner layer of the uterus, lined with glands. When the endometrial tissue becomes malignant, it makes glands as it grows. We call that an endometrial adenocarcinoma. Here's an example. In other instances, carcinomas don't make glands as they grow. They just grow as big sheets of cells. Again, no resemblance of glands at all. A good example might be a squamous cell carcinoma of the skin. Squamous cell carcinoma of the skin doesn't make glands as it grows. It just makes big sheets of nasty-looking squamous cells. No glands to be seen. So that would be an example of a non-adenomatous squamous cell carcinoma of the skin. It's not glandular in nature. It's non-adenomatous. Okay, so this is kind of the layout of the hierarchy of malignant neoplasms. Again, malignant neoplasms are even subclassified further. Their subclassification is very complex. Some of the different subclassifications based on immunologic profiles and what receptors they're expressing. Again, we subclassify them to death, literally, because we want to tailor specific chemotherapeutic treatments for individual cancers so we can maximize effect, minimize side effects. And so this has been a very exhaustive kind of subclassification scheme that's developed. Okay, any questions on that? All right, let's take a look at some malignant neoplasms. So we looked at benign neoplasms. Let's have a look at some malignant neoplasms and see what the difference between benign and malignant is. Let's first take a look at an example of a malignant proliferation of fibroblasts. And we said, when we name a malignancy, we consider the cell of origin. Is it a carcinoma or is it a sarcoma? Let's consider a cell that's proliferating, it rises from mesenchyme, it's going to be a sarcoma. How do we name such a proliferation? Well, we take, again, the parenchymal name of origin, and we just add the ending sarcoma to it. So a malignant proliferation of fibroblasts, since they come from mesenchyme, would be called a fibrosarcoma. Let's take a look at that. Let's first take a look at fibroblasts again. First, normal fibroblasts. Again, we can see normal morphology of these nucleus. We can see the density of the cells nicely laid out. They're all very dispersed. They're not crowding each other. That's normal density of fibroblasts. Okay? That's what normal fibroblasts look like. Here is what fibrosarcoma cells look like. Okay, it's a section through a fibrosarcoma. Nearly all the cells you're seeing here are fibrosarcoma cells. Take a look at this. Again, you notice the cellular density. Some areas are more dense than others, but the cells are very tightly packed together. Again, it's a manifestation of loss of proliferative control. These cells are proliferating out of control. They are neoplastic cells. Take a look at the individual cells, the individual fibrosarcoma cells. Look at the nuclei. You see how a lot of these nuclei don't resemble the nuclei of the normal counterparts? Okay, maybe some of them do, but most of them don't resemble the normal counterparts at all. When you have a neoplasm consisting of cells that do not resemble their normal counterparts in either appearance or function, we call these neoplastic cells poorly differentiated. Poorly differentiated. Generally speaking, malignant neoplasms consist of poorly differentiated cells. Is that always the case? No, but it is a strong correlate. If you are looking at a sample of neoplastic cells like this one, and you haven't the luxury to examine local invasion or metastatic dissemination, you're going to have to base your decision on whether that tumor is benign or malignant based on correlates, including things like differentiation. You look at the cells, they're poorly differentiated. Well, most likely, a neoplasm consisting of poorly differentiated cells is going to be malignant. Could you be wrong? Yes. But you'll be right most of the time. If you base your decision on how poorly differentiated the cells are, you'll be right most of the time. Any questions on that? All right, let's take a look and compare the different types of cells. So we've examined fibroblasts that are normal. We've examined a benign proliferation of fibroblasts, fibroma, and we've examined the malignant proliferation of fibroblasts, fibrosarcoma. Take a look. Compare the degree of differentiation. Okay? Normal cells. Okay? Take a look at the fibroma cells. The fibroma cells look like their normal counterparts. These are examples of cells that are well differentiated. Look at these fibrosarcoma cells. Most of them don't even look anything like their normal counterparts. These are poorly differentiated. Okay. Differentiation is often a correlate we use to determine whether a tumor is benign or malignant. If the tumor consists of well-differentiated cells, chances are it's benign. If they consist of poorly differentiated cells, chances are it's malignant. Okay. Anything on this? All right. Let's take a look at a few examples of carcinomas. So we talked about the sarcomas. Let's take a look at some carcinomas. What is a carcinoma? A carcinoma is a malignant proliferation of cells that originate from one of those three germ cell layers: the ectoderm, the mesoderm, or the endoderm. Okay? got a proliferation of cells that originate from one of the germ cell layers. We call it a carcinoma. Two main types of carcinomas: adenocarcinomas, that make glands, and non-adenomatous carcinomas that don't make glands at all. Let's take a look first at an example of some carcinomas. Let's first take a look at an example of a squamous cell carcinoma. Let's take a look at a squamous cell carcinoma of the skin. First, let's look at normal skin. Okay, you can see normal skin here. Section through the skin, there's the epidermis right there. There's a basement membrane right there. And there is the dermis underneath the epidermis. Okay. Here's some normal epidermis. You can see different layers of the epidermis you learned about in some of the other classes. There's the stratum basalis there. There's the spinosum. There's the stratum granulosum. And there's the stratum corneum right there. Take a look at the cells. Again, in the stratum basalis, they're all crowded together, high NC ratios. They're immature looking. They're supposed to be, because those are the cells that are proliferating to constantly replenish your skin as your skin exfoliates. Okay? But as they migrate upward in the epidermis, notice the morphology changes. The nucleus gets a little smaller, cytoplasm gets a little bigger, the NC ratio declines. This epithelium, this epidermis, is maturing properly. Okay, that's what normal epidermis looks like. Let's take a look at an example of squamous cell carcinoma just before it becomes squamous cell carcinoma. Here's a section through skin. There's the epidermis right there. There's a basement membrane, and there's the dermis right there. This is the dermis, and that's the epidermis. Okay, take a look at the cells in this epidermis. What do they look like? Number one, are they crowded together? Yes, they are. Do they look mature to you? They don't. They got big NC ratios. Do they look kind of uniform? Or did they look all different from each other? Different from each other. And we got a term for that. Many forms. They're pleomorphic. They're very different from each other. They're mutated all over the place. Look at that. Okay. They're all very crowded, and despite the fact that they're crowded together, we got this over here. That's a mitotic figure. Mitotic figure. The cells are dividing despite the fact that they're all crowded together. Okay? This is an example of a pre-squamous cell carcinoma. Now, there's a basement membrane that runs underneath here. Okay, it's a natural tissue barrier. These cells haven't quite gotten to the point of breaking through, but they will at this rate. This is an example of a squamous cell carcinoma just before it begins to break through the basement membrane. Okay, very strong proliferation of cells, okay, very polymorphic, and you got mitotic figures. Okay, any questions on this? All right then. It's important to understand some of the defining features of malignancy and some of the correlates of malignancy. On an exam, you're going to get questions where you're going to have to determine whether the tumor is benign or malignant. A tumor is benign or malignant. So if I were to say something like, a man presents with a tumor on his right forearm. The tumor has well-defined boundaries. What is it? Is it benign or malignant? It's benign. It's more likely to be benign because those well-defined boundaries most likely will tell you there's no local invasion. And if I said a child presents with a mass on his forehead which has irregular boundaries and blurry borders, probably malignant. Clinically, you pretty much can tell the difference between a benign and malignant neoplasm just by looking at the tumor. just by looking at some of the characteristics of the tumor. Could you be wrong occasionally? Yes. What will determine it? You have to look at the microscopic architecture. But ultimately, you'll probably be right 80 to 90% of the time just by looking at the gross appearance of the tumor. Okay. Let's take a look at some other things. All right, so we've looked at benign malignant neoplasms. We know generally their behavioral characteristics. Let's talk about a couple of terms that are used to describe various components of neoplasms. The words parenchyma and stroma. You've heard me use these words before. Okay. These words have different denotations depending upon the context in which you're using them. We can use these terms to describe components of normal tissue. We can use these terms to describe components of neoplastic tissue. Depending on which context, those terms mean slightly different things. Let's take a look at these terms as they would be used in the context of describing components of normal tissues. Okay, parenchyma. Parenchyma is a component of a tissue that specializes that tissue. It does a specific specialized work of that tissue. For example, liver. Liver is composed of a number of different tissues, some of which are hepatocytes, liver cells. These hepatocytes are the special cells of the liver. They do the special functions of the liver. Okay, they filter the blood, synthesize proteins. Okay. The hepatocyte would be described as the parenchyma of the liver. But the liver isn't just made out of hepatocytes. It's got a connective tissue framework. It needs that connective tissue framework, otherwise it would have no form at all. It's got blood vessels to service it. What do you call this connective tissue, the blood vessels? Well, you call that collectively stroma. Stroma is just about everything else other than the parenchyma. It would include things like connective tissue and blood vessels. So the parenchyma is that specialized tissue of the organ, and the stroma is everything else, the connective tissue framework and the blood vessels. Okay, that's what these words generally mean in the context of normal tissues. But we also use them in the context of neoplastic tissues to describe the components of the neoplastic tissue. In this context, they mean slightly different things. Parenchyma. In the context of a tumor, the parenchyma is that part of the tumor which is neoplastic. It's the cells that are proliferating out of control. But a tumor isn't just made out of neoplastic cells that proliferate out of control. A tumor needs blood vessels, it needs blood supply to survive, and it also needs a connective tissue framework. The blood vessels in the connective tissue framework are not neoplastic. They're just there because the tumor is recruiting the connective tissue and recruiting the blood vessels so it can survive. What do you call that other tissue? The stroma. The stroma of the neoplasm. The connective tissue, the blood vessels. So in this context, using these terms to describe the components of a neoplasm, the word parenchyma refers specifically to the neoplastic component. The stroma refers to all the supportive tissues, the blood vessels, the connective tissues. Now, one thing you'll find very different about parenchyma and stroma between normal tissue and neoplastic tissue. Usually in normal tissue, there's a balance between parenchyma and stroma. You've got parenchymal cells that are supported by a certain proportion of stroma and blood vessels. Okay? They obviously need support, they need blood flow. Okay? There's a certain proportion of parenchyma to stroma in normal tissues. Neoplastic proliferations, neoplasms, tumors, you'll find the parenchymal component is well out of proportion to the stromal component. There's a lot more parenchyma than stroma. The reason for that is the parenchyma is growing out of control. That's the neoplastic component. The stroma is actually normal. It's just being recruited by the neoplasm. It's not growing out of control. And as a result, the parenchymal component is well out of proportion to the stromal component in a tumor. There's a lot more parenchyma, a lot more neoplastic cells than stroma in a neoplasm, in a tumor. Okay, let's take a look at this. Let's go back to the thyroid. Thyroid's a perfect example to show you what parenchyma and stroma look like. Let's go to the normal tissue first. Here's normal thyroid. Okay. I've already pointed out what the stroma is. Okay. You've got the glands here. And you've got a lot of connective tissue and blood vessels here. It's called the stroma. Okay. The glandular component of the thyroid is what makes the thyroid special. It just happens to be also called the parenchyma. The parenchyma of the thyroid are these glands. This is the parenchyma, that's the stroma. Now notice that the glands, the parenchyma, are always surrounded by lots of stroma. You've got stroma all over the place. Some of the glands sit up against each other, but there's lots of intervening stroma. Plenty of stroma for all the glands. Okay. Take a look at the neoplasm. Here's the tumor, consisting of glandular tissue. This is an adenoma. Okay. What's the neoplastic component? Well, these glands are the neoplastic component. This is the parenchyma, consisting of neoplastic glands. Look at the stroma. Where's the stroma? There's not much of it. You have to look real close. Well, here's a little bit of stroma. Do you see a whole lot of stroma in here? No. Why? Because it's not neoplastic. The parenchyma is neoplastic. The stroma is trying to keep up with the proliferation of the neoplastic component. It's not doing a good job. It's actually falling behind. There's very little stroma in here, but a lot of parenchyma. And this is typically what you will find in tumors. The parenchyma is well out of proportion to the stroma. Let's take a closer look. Zoom in here. Here's a close-up shot of the follicular cell adenoma of the thyroid. Again, I can see lots of glands here, but there's very little stroma. I mean, maybe there's a little stroma here. Get back. There's mostly just glands back to back in here. There's very little intervening stroma. Look at the proportions. I mean, the parenchymal component is way out of proportion to the stroma. That's true for most tumors. Any questions on that? One more thing we need to talk about before we go today. Concept of monoclonality. You've heard this word monoclonal. Monoclonal antibodies? You've heard of these. Monoclonal. What the heck does monoclonal mean anyway? Monoclonal usually refers to a neoplasm. Remember how we talked about the evolution of a neoplasm? Neoplasm starts off with one cell. That one cell divides into two daughter cells that are virtually identical to each other. Those two daughter cells give rise to four daughter cells, virtually identical together. 4 to 8, 8 to 16, 32, etc. Initially, when a neoplasm proliferates, one cell loses proliferative control that gives rise to daughter cells that have same genetic material. They're virtually clones of each other. This clonal proliferation expands. This clonal proliferation originated from one progenitor cell, one, mono. A monoclonal proliferation. Monoclonal expansion, that's what we mean by monoclonal. Monoclonal expansion is just a proliferation of neoplastic cells that have originated from a single progenitor cell, monoclonal. Monoclonal antibodies, where do they come from? They come from plasma cells that are neoplastic. All you have to do is program a neoplastic plasma cell to produce the antibody you want, and you got monoclonal antibodies. Okay. Let's take a look at an example of monoclonal expansion. Now, again, monoclonal expansion is just a clonal expansion from a single progenitor cell. Initially, when a cell loses proliferative control, the cell is going to give rise to these daughter cells that look identical because they're genetically identical. However, as time goes on, these daughter cells are going to mutate. Eventually, they won't look anything like each other, and they're very pleomorphic. But at least initially, the cell proliferation consists of cells, all of which have the same genetic material and look identical. Here's an example of a carcinoid tumor, okay, demonstrating monoclonality. And look at the cells of this neoplasia. Don't all the cells look alike? Cells look alike. This is what we describe as a monotonous population of cells. That's a manifestation of monoclonality. They all look alike. They're all genetically identical. Now, that's true initially. The cells are all genetically identical. But as we said before, as these cells continue to proliferate, they're genetically unstable. Eventually, they mutate, and they all become pleomorphic. They don't look anything like each other. Okay. Any questions on this? Okay, tonight, we're going to study the most important slide in the whole presentation. That's this one. We're going to compare some of the characteristics of benign and malignant neoplasms. Make sure we understand them. If you understand this chart, I mean, you really understand it, you should have no trouble with the exam at all. You have to make sure you really understand it. Anything? Okay. In that case, we'll see you tonight.
Lunchbox dust? Yes. I was trying to make stuff for today. I literally just packed turkey in oil.
Where's the microwave in this place?
Downstairs. I have to go too. I'll show you.
No, go on the.
Oh, there is one. It's old fashioned.
You said it's old fashioned.
It's a knot. I don't know which one's Because I was in a rush, I was like, I'm not spending money on Chipotle today.
Nice bowl. whole chicken off.
Yeah. My Graham's full.
I need sleep.
If you went to Starbucks, we went somewhere else.
Yeah. Two opposite ends of the spectrum.
It's so deep. I love Miles. I mean, who's gonna in the what?
Chips. The good chips.
No, actual text.
Is this on or?
I don't know.
I mean, it's off, kind of. Brody 123.
Yeah, Captain.